Good evening, students. I would invite Gurvinder sir to start the session.
Hello everyone, am I audible?
Yes, sir, you're audible.
Okay, thank you. Yeah, we will start today's session. Uh, so, hi.
Good
So,
evening.
hi, good evening everyone. So, before like moving ahead or discussing anything else, I would want to discuss the yesterday's question that we had that I had given as homework. Okay. So just in case if anyone has done it, please inform. Or if you have not done, then also please inform. Just tell me that we couldn't do it because like it was a bit tricky and important problem. So no worries if you have not done also because I'm going to do it now. So has anyone tried it or has anyone done it? Many, I guess, don't even know what the question was, right? So the question was y is equal to ax cube plus bx square.
Plus AX plus D.
Yes. And what was the domain? X was belonging to all real numbers, right?
Yes, sir.
Yes, sir.
Hmm. Okay. No worries.
F of X is bijective, sir. Y is.
Yes. It has to be bijective. Yes. I was just looking for the question. Yeah. So I need to find the condition. Like, what is the condition if this has to exist?
Yes, sir.
Okay. So if this has to exist, okay. So just think bijective means what? It has to be 1 1 and it has to be onto also, right? The function was mapping from all real numbers to all real numbers, right? I had given you this. So basically its range will have to be all real numbers and it has to be 1 1 also. So before moving through it, is there something that I already know about the function? There is already something that I know about the function. If you look clearly, uh, can you tell me what will be the value of these two things? Can you tell me if I put x tends to infinity, if I am putting x tends to infinity, what will my y tend to? See,
Minus
A, B,
infinity.
C are see my A, B, C are nothing but basically just numbers, right? Just real numbers. So it is ax cube plus bx square plus cx plus d. A, B, C, D are basically real numbers, right? So if I am uh, putting a very huge value in place of x, if x is tending to infinite, tell me what will be my value of y? What will my value y tend to?
Minus infinity.
Minus infinity. So, so x cube plus x square plus x plus 1. If you put x tends to infinity, will it tend to minus infinity? Say it again.
Infinity, sir.
It's just infinity.
Okay, it is infinity. Now you're saying it is infinity. Now I will change the question. Now I am telling you minus x cube minus x square minus x minus 1. Now I am
Minus
putting x tends
infinity.
to infinity. Now it will go to minus infinity.
Minus
Correct.
infinity.
What if I do something like this? Minus x cube plus x square plus x plus 1. Where it will go now if x is tending to infinity? Tell me. It is
Minus.
minus x cube. Where
Downwards.
will it go? Where will it go?
Down.
Minus.
Correct. Minus infinity. Why? Because like this x cube has the
Value
highest
is
power. So since it has the
x.
highest power, so it has the highest strength. Like it can I can neglect all of these values. Just look at the highest power, right? Because it
Yes.
has the largest number, right? It has the largest degree. So yeah, you are absolutely correct. So like it would depend on my value of a basically on the first. Uh, so it would depend on my value of a. Yes, it would, right? So if my a is positive, if my a is positive,
X is equals to plus of A.
yes, correct. If my a is positive, so my y will tend to infinity. Or if my a is negative, my a is negative, and I have already for sure like you know
Is
this condition, right? So y will tend to minus infinity. Correct?
Yes, sir.
Yes, sir.
Correct. Similarly, tell me what if I make x tends to minus infinity, what will happen? What will happen if I make x tends to minus infinity?
A is greater than 0.
So for a is greater than 0, y will tend to minus infinity. Correct?
Minus infinity.
Because a is correct. Similarly, the sign will opposite over there. Correct?
Plus infinity.
Yes, sir.
Correct.
Infinite. Mm.
Now what you do, you look at this case and this case separately. So just see, okay, that when my a is greater than 0, my value of y is ranging from minus infinity to infinity.
Infinity.
Similarly, when my a is lesser than 0, still my
Infinity to
y is
minus
also
infinity.
ranging from, yes. So that means, what does this mean? Like I am getting this value, like I am getting this range, no matter if I am taking a is positive or I am taking a is negative. So I can say no matter what the value of a, b, c, d is, this function, the range of this function is definitely minus infinity to infinity. That is all real numbers. So I will write it down over here. Okay. That is also called R, all real numbers, right? So no matter what my value of A is, if it is positive or negative. See here also, if A is greater than 0, I was getting infinity. If A was greater than 0, I was getting minus infinity. Similarly, if my A was negative, so I could get the value minus infinity. And if A was negative, I could have gotten the value infinity. So ranging from minus infinity to infinity, no matter what value of A I take, if it is positive or negative,
Or
I can
negative.
get all real numbers, right? Right? I
Yes,
can get
sir.
all real numbers. Okay.
Yes, sir.
So that means onto is confirmed. Onto हो गया मेरा confirm, है ना? Because see, what was my function mapping to? My function was mapping from all real numbers to all real numbers. So this thing has been confirmed that my range is equal to all real numbers. This is confirmed. Correct? This onto wala cheese, it is confirmed. So now I will move to checking if it is one. यार onto वाला समझ आ गया ना? How this onto is being confirmed.
Yes,
Anyone
sir.
who has any doubt? Anyone who has any doubt about how this onto is being confirmed? Right? Because no matter if you take a positive or you take a negative, my y will definitely be from minus infinity to infinity. So my range is equal to this set B, that is all real numbers. So now I will check for 1 1. Now I will check for 1 1. Now, this is a bit critical part, but not very tough. No need to worry. Okay. So, okay. So now I have to check my 1 1. So I have my y is equal to ax cube plus bx square plus cx plus d. Okay. I have this. Now, obviously, if I have to check 1 1, I will have to check if it is increasing, decreasing, all that. So I will need to differentiate it, right? So tell me derivative fast. Please tell me the derivative.
3a
3x square, 3ax square. Okay, okay,
plus
2bx
plus
Yes.
okay,
plus c.
okay. Plus c, correct. Absolutely correct. Okay, that's absolutely correct. No need to worry. So, is there something that I already know about dy by dx, or do I need to again figure out? See, just remember this case. Whenever it is 1, 1, okay, whenever it is 1, 1, so either it will be purely increasing, wherein my dy by dx is greater than 0, or it will be like something like this, where entirely my all values of dy by dx will be lesser than 0. So, just looking at this thing, can you guess which case should it belong to? I can see, like I am able to see that, yeah, one case, definitely one of these cases should, like this function should belong to either of these one cases. Like only then it can be 1, 1. Otherwise, it can't be 1, 1. Okay. So tell me, which case should this function go to?
Greater than 0.
Yeah, obviously. Why? Like it is very easy to prove. How can you do it? You put x is you put x tends to infinity. So my dy by dx will also tend to infinity. Similarly, if you put x tends to minus infinity, still my dy by dx will also go to minus infinity. Sorry, it will go to infinity only. Sorry, it will go to infinity. So like it is remaining positive. You go either side on x-axis. You go either side on x-axis. My dy by dx is remaining positive. So that means my at all points, at all points in domain, at all points in domain, my dy by dx has to be greater than 0. In other words, I can also say that the least value of dy by dx has to be greater than 0. I can also say this: if my all values of dy by dx in my domain are greater than 0, I can also say that my least value of dy by dx has to be greater than 0. Right? If my least value is greater than 0, then I can for sure say, yes, do you have a doubt? Do you have any doubt? Okay, I can say this thing, right? Shravani, are you there? Do you get this? Okay, like, see, see what the whole class told me, yes. So I am erasing that second case. So my first case is absolutely correct. My dy by dx has to be greater than 0 at all points. At all points in my domain, my dy by dx has to be greater than 0. So from this, I can also say that my least value of dy by dx, the least value of dy by dx will also be greater than 0. Obviously, if all my values are greater than 0, so my least value will also be greater than 0, right? It has to. So coming back again, I have this function dy by dx, okay, 3ax square plus 2bx plus c. Okay. So tell me, what will be the least value of this function? Like, what will be the least value of dy by dx? Do you know this? Yesterday we had done, like yesterday also we had used this thing now. Tell me, you have a quadratic equation, something like this. And obviously with a is greater than 0. So tell me, what is the least value you get?
d by 4a.
D by
Is
4a
it d by
common.
4a? It is minus d by 4a.
Minus D by 4.
Minus d by, yeah. So basically, my minimum value of dy by dx, least value of dy by dx will be equal to minus b by 4a. But now just look and compare. So my a will be 3a, my b will be 2b, and my c will be c only. Okay, I need to change this also, na, from here to here, because my a, b, c have changed. So now tell me, what will be my value of d? What will be my d? It is b square minus 4ac. So b square, that is 4b square minus 4ac. So it is 4b square minus 12ac, right? This is my d. So my least value, what will be my least value? Minus d by 4a. So minus d by 4. But in place of a, I will be writing 3a, right? Right? So tell me, can we do this? Can something be done? So it is basically 3c, right? Okay, so just leaving it this way only. I'll just leave it this way currently. So my least value, dy by dx, least value, minimum value, is basically this much. 12ac minus 4b square by 12a.
Well,
Correct? This is my least value of dy by dx. And I am telling you, this has to be greater than 0. This has to be greater than 0. That's it, or can I simplify it more? Yes, I can simplify. How I can simplify? Just take out the constants. Just take out 4 from numerator and 12 from denominator. So like you can take out the constants, right? So it is basically 12. So on top I can take out 4. So it is 4 into 3ac minus b
base.
square by uh, 4 into 3a, right?
Yes, sir.
So basically, in other words, I can also write it as 3ac minus b square by 3a is greater than 0. This will be my condition, my final answer. This is my final answer. This is my condition. Fine. Any doubts? Any doubts in this question? Or should
No,
we
sir.
move ahead? Okay, great. So yeah, yesterday we were discussing something related to inverse functions, right? So basically inverse is nothing. Just think of it like this. You have a function y is equal to f of x. You have another function y is equal to f inverse of x. Uh, See, this thing is not this, okay? There is a difference between these two things. 1 by f of x is different and f inverse of x is different, okay? If I write f of x whole to the power of minus 1, this can be written as 1 by f of x, okay? This thing and this thing are not the same, okay? So y is equal to f inverse of x. So basically, like you put any value x, it will give you the corresponding value of y. Okay. Now what will happen over here is you are giving me some value of x. Okay. You are giving me some value of x, but it will tell you, like it will take this function as a reference function and it will tell you what value of x you had put in over here so that you got this particular value of y that you are inputting, like this. So just for an example, I have y is equal to x cube plus x square plus 1. Okay. Okay. So let me not take it. Okay. So 3x cube plus 5. Okay. Let me just take it this way. Okay. So this is my function f of x. Instead of writing y, I will write it as f of x. And it's like f is mapping from all real numbers to all real numbers. Okay. So tell me, what will be my f inverse of 8? What will be my f inverse of 5? What will be my f inverse of 32? Okay, this is like just the basic question to start explaining how inverse works. I have my f of x, 3x square plus 5. See, if I'm giving you the inverse, if I'm asking you the inverse of function, so you will already assume that the function is invertible. Okay, the function is bijective. You can already assume, you can just assume that thing because that is why the question is being formed. Or else they will ask you that is this function invertible? If yes, then find its inverse. Okay, if it is not given, just assume that f of x is invertible. And in this case, I have chosen a function that is invertible. Okay, so yeah, tell me, what will be my value of f inverse of 8? See, now just imagine how f inverse is acting. Okay, this is my function f of x. Okay, I have another function f inverse of x. So basically, what is f inverse of x? So whatever value you are putting inside it, let me take it 8. So this f inverse will tell me, this f inverse of 8 will tell me what value of x that I had to input in f of x so that I got the final value as this. Fine. So tell me what value of x should I put in f of x so that I get my final result as 8? Should I write it or how should we do it?
Sir, it is 1.
Yes, like yes, it is 1. Okay. See, I am inputting a value over here. Okay, then what is it telling me? It is telling me what value I should have inputted in f of x so that I got the value that I am inputting over here. Okay, just the opposite, replica. Just see it as a replica. So this function will just give me, okay, see, I have f of x is equal to 3x cubed plus 5. Okay, so I'm asking you, f inverse of 8 is basically means what? It means what value of x, find x such that f of x is equal to 8. It is basically telling me this thing. If I'm telling you find the f inverse of 8, I'm basically asking you to find such value of x where f of x is equal to 8. Okay, this is basically what I'm asking you to find. F inverse means that. So tell me, what will be the value of x that I need to input so that I get
10.
what? 10?
Sir,
1, sir.
it is 1,
Hi,
sir.
1. 1, correct. If I put x is equal to 1, I will get my f of x as 8. Similarly, tell about this.
Sir, for 5,
No,
it is 0, sir.
0.
0, correct. What about this?
Cube root of 9, sir.
Correct. 9 raised to 1 by 3 also I can write that, right?
Yes.
So now from this example, is inverse clear to you? Or do we need to practice some more questions? And see, it is not always possible. It is not always possible that you get inverse in the form of a complete function. See, I'll just show you with an example. See, I have a function f of x that is, let me take x cube, okay? I have a function x cube. So I can say that my f inverse of x is equal to x power 1 by 3. Okay. Like you can prove it also, like using the method that I had taught you yesterday. But many a times what happens is my function becomes very, very, very complex. Okay. Something like this. If I have something like this and I am asking you f inverse of x of some value, so this thing may not entirely be a function. Okay. This may not be a function, be a well-defined function. It is possible. Okay. It is possible. So yeah, like this was just to tell you that inverse may or may not be a well-defined function. Like for example, you have x cube. Okay. You have x cube. So its inverse is definitely x raised to 1 by 3. You can just easily take x power 1 by 3. That will be the inverse. You put any value and I can tell you, but the same won't be happening over here. It may or may not be a well-defined function. Okay, so just a few more practice problems. So I hope you guys remember how we used to calculate the inverse of a function. If not, I'll just show you one question. Okay. And after that, we'll be moving ahead. So my f is mapping from minus infinity to minus 1. Okay. To all real numbers except for 1. Okay. And my f of x is being defined as x divided by x plus 1. Okay. So find f inverse x. So see, it is really, really simple. What you used to do when finding the range. What we used to do when finding the range. So like if I have a function something like this, I will try to write it down something like this. So I will try to separate out the values of x and y. So cross multiplying over here, it is xy plus y is equal to x. Okay. Then y is equal to xy minus y. So it is basically x into 1 minus y. So my x is equal to y divided by 1 minus y. This is my x in terms of y. Now what I do? I need to find f inverse in terms of x, right? I need to find in terms of x, like the input I am giving is x. So if the input I am giving is x and I am getting this function in the form of y, so I can just easily replace y with x, right? Just replace y with x. So my f inverse x will be
Sir.
x of 1 minus. Yes, yes. Do you have a doubt?
No, sir.
Okay, okay. Ashita, you got this right?
Yes, sir.
Okay,
Understood.
okay, okay, great. Good to hear that. I hope everyone is clear with how we did it. देखें कौन है? Shravani, did you get it?
Yes, sir.
Okay, great.
Can you repeat once again?
Yeah, sure, sure. See, I have f of x is equal to x divided by x plus 1. Please, like, these things are sometimes given just to confuse you, okay? No need to look at this. No need to look at this unless they are asking you to check the invertibility or not, okay? See, I will just look at this thing. My f of x is equal to x divided by x plus 1, okay? So, I will try to write my x is equal to and all y on one side. Okay, I have y is equal to f of x, and I will try to write it in terms of x is equal to g of y, like x is equal to some function of y. So x is equal to like x is equal to and all terms of y on this side. I will try to write it like this. So what did I do? I separated out my y and x using cross multiplication. And I got this x is equal to y divided by 1 minus y. But I am asking you to find f inverse of x. Okay, I am asking you to find f inverse of x. So basically, I am giving the input, I am naming the variable as x. You are getting the variable as y. If I am asking you to find the value of f inverse of y, so you can just say it is y 1 minus y. Because the input is y and everything calculation is going on in terms of y. So this will be correct. But I am asking you to find the f inverse in terms of x. So everything that was in terms of y has to be converted in form of x. So everywhere you see y, just replace it with x. That's it. That's what I'm trying to say. That if you had to find out the value of f inverse of y, so you can just take this thing, x is equal to this thing, whatever you got, and just say that, sir, this is my f inverse y. But I am asking you to find f inverse x. So just replace your y with x. That's it. Okay. So tell me, so just a few problems. So I have y is equal to e raised to x. Okay. Find its yeah, y लिख देता हूँ मैं बार बार f of x. Okay. So tell me what will be its f inverse of x. Similarly, second, I have f of x is equal to e raised to x into x minus 1. So find f inverse of x. Just think, like you just need to think carefully. Okay. It is nothing complex. So see, I have got y is equal to e raised to x. So tell me, can I separate x and y? Is it possible?
Yes, sir.
No. Tell me how? कैसे करोगे? No किसने बोला था? Was there someone who said no, or maybe I just okay? Yes. How we can do it? Please tell me. Srija, right? Yeah, please tell me. Like anyone can see, there is an answer for sure. I need to write it in terms of x is equal to some function of y. Okay, I need to write it like this: x is equal to and all terms of y on one side. Tell me how can I do it? How can I do it? Okay. So see, if y is equal to e raised to x, I will tell you take natural logarithm on both sides. Okay. Okay. Take natural logarithm on both sides. So I have y is equal to e raised to x. So I can say ln of y is equal to ln of e
Of
raised to
yes.
x, right? So tell me what will be my right hand side equal to? Ln of e raised to x. What is ln of e raised to x?
Y.
Ln of e raised to x is y. How? Like ln, you all know what ln means, right?
No, sir.
Ln means log, natural log, like, okay, no issues. See, ln means log base e to the power of x. Okay, this is what it means. Ln, it is called ln, natural log. Okay. So can anyone tell me what will be its value? Log base e raised to x. So first of all, you should know what this means, like what this thing means. Logarithm you all know, right? Is there anyone who doesn't know what logarithm is? Bhavna, Gayatri, Ashrita,
Sir,
Manoj. Yes, tell. Yes,
E
yes.
log X log
E,
E to E, sir.
x. Correct,
X
absolutely
log
correct.
E base
So,
E.
so like, is there something we know? Yeah, just think clearly, na. What about this thing? Do I
Hmm.
know this? What is this? Tell
Hmm.
me, what is the value of log E? Log
One.
e
One,
to the
sir.
base e.
One.
Absolutely, it has to be one. Like, it is basically asking me what power should I raise? What power should I raise e so that it is e? So obviously it is one. So yeah, it is
One.
x only, right? It is x. So my
Hmm.
right hand side is basically just x. So my x is
Yes.
equal to ln of y. So my x is
Yes,
equal
sir.
to ln of y, right? So if my x is equal to natural log of y, can I say my f inverse of x is equal to ln of x?
Yes,
Yes,
sir.
Yes,
sir.
sir.
है ना?
Yes.
आ गया? Now you got it?
Yes, sir.
Okay, great. So just moving ahead with this one. This one I'll be solving and giving you a bit tougher problem as homework. Okay. So y is equal to e raised to x into x minus 1. Okay. E raised to x into x minus 1. So obviously, first step will be, obviously I will have to take natural log. So ln of y is equal to ln of e raised to x into x minus 1. So tell me, what will be this thing equal to? X into x minus 1 is basically like just multiplied. So no need to worry about that. So tell me, what will this thing be equal to? This thing. Natural log e raised to x into x minus 1. So I have log base e raised to x into x minus 1. So can I again take x into x minus 1 as one entity and take it outside? So it is x into x minus 1 multiplied by log base e, right?
Yes, sir.
Just treat
Yes,
x
sir.
into x minus 1 as a singular identity, as one single unit. X into x minus 1 is just basically my one single unit. Okay. So basically it is x into x minus 1, right?
Yes, sir.
Yes.
Yes,
Any
sir.
doubts? Right? Any doubts?
Not, sir.
No, sir.
Okay, great. So basically my x into x minus 1 is equal to ln of y. Okay. It is equal to ln of y. And I need to write it in terms of x is equal to g of y. X is equal to g of y. So taking it out this side, it is x square minus x minus ln y is equal to 0. So I will need to solve this quadratic equation. I will need to solve the quadratic equation. How will I solve it? Tell me. Just use the formula directly, minus b plus minus under root b square minus 4ac. So my a is equal to 1, b is equal to minus 1, c is equal to minus ln of y.
Then
Okay.
I.
So my x is equal to, tell me what will be my x equal to? X is equal to minus b, that is 1, plus under root b square, okay,
One.
minus 4ac whole divided by 2a, right? Any doubts?
Yes, sir.
Correct. It will be this.
Yes, sir.
So tell me, what
Yes,
will be
sir.
my f inverse of x? I have got my x in terms of this. So tell me, what is my f inverse x?
One plus root one plus
Hmm.
Under root
n
1
of
plus 4.
2. Exactly. You were just supposed to invert the values of x and y. Just invert the values of x and y, and that is your answer. So your answer is 1
plus
Under
under root
root
1 plus 4 ln
plus
x.
4 ln y.
4
Yes, sir.
4
ln x.
ln x whole divided by 2.
2.
Right?
Yes, sir.
Just invert the values of x and y. That is what I am speaking. What I am telling you, just invert x and y, and that is your answer. Yeah, that's it. So just one homework problem also. So homework problem is my f of x is equal to natural log of x plus under root x square plus 1. Okay, this is my f of x. So just before moving ahead, just one small problem. My f of x is equal to uh, natural log of x. Can you tell me what will be its inverse? Can you find its inverse? So my y is equal to ln of x. Tell me what will be my f inverse? How can you do it?
X square.
It's where? No.
X, sir.
Just think like uh,
Y, sir.
y, like how can your f inverse x be y? Like it has to be in terms of x, na? Like that is why like I am explaining you the concepts. F inverse can't be in terms of y. It has to be in terms of x. That is why we were inverting the variables over here.
Root
Just
X.
root x, okay? Still wrong. You like just go back to the basics, okay? Go back to the basics. So y is equal to basically log base e of x. Okay. So tell me, how should I write it as something like this? I want to write it as something like this. What can I do? From this step, I want to come here. What can I do? Tell me. From this step, I want to come over here. So just think, how can I get rid of this natural log? So, okay, no worries. So basically, like it's very simple. Just think opposite. Earlier, we were taking log when we had exponent. Okay. Earlier, see, I'll just go a bit up ahead. See, here we had exponent. So we were taking logarithm to get rid of this exponent. Now I have a logarithm already. So what can I do to get rid of it? I will raise both of these to exponents. So I will basically exponent. So I will raise both my LHS and my RHS to an exponent e. So my e raised to y is equal to e raised to log base e of x, right? Do I know something about this right side? Was there
Yes.
a property? Tell me, what is the property? What will be this thing equal to?
X, sir.
X.
X.
Correct. Absolutely correct. It is equal to x. So my e raised to y. So basically my x is equal to e raised to y.
Yes, sir.
So tell me, what is my f inverse x equal to?
E power
I
X.
have, correct. Just invert, na?
X, sir.
Correct. You got it? Just
Yes,
look,
sir.
just observe one thing from here. I had given you f of x as e raised to x. Okay. You got its f inverse of x as ln of x. Okay. When I am giving you f of x as ln of x, so you are getting f inverse of x as e raised to x. Do you infer one thing from here? Yesterday, a property of inverses that I had taught you, that f inverse of, sorry, like this is f inverse of x. Okay. Okay, this is f inverse. If I take its inverse again, so basically f inverse of x, it will basically be equal to x. So basically inverse of inverse. Oh, sorry, it will be f of x. Inverse of inverse is basically just the function itself. Fine. You can try it here also. Wait a second. Will it be okay? F inverse of f. Oh, sorry. It will be x, not f of x. It is x. Okay. Fine. Like basically the point I'm trying to make is you have a function e raised to x. You take its inverse, so it is ln x. And when you again take its inverse, so it will get you back to the function. So f inverse of x is basically x. Fine.
Yes, sir.
Okay. So yeah. So just do this homework, okay? With this. So just think how you can do it. So obviously, like it is very clear that the first step will be obviously raising both of these sides to exponent powers. Okay. First step is like very clear. Okay. Okay. So yeah, moving ahead, just a few terminologies. So we have even and odd functions. So first of all, what is an even function? Okay, what is an even function? So even function is basically any function whose f of minus x is equal to f of x. Like it is symmetric about y-axis, right? So basically, like this is my x and y. F of x and minus x is basically the same. So if it is something like this on the right side, so exactly opposite will be over here, right? Because same distance from here, same distance from here, it will fetch me the same result. So its curve is symmetric about y-axis. Like I have some examples also. Uh, we have y is equal to cos x. Okay. Then we have y is equal to x square. Y is equal to x raised to 4. So either you put x or you put minus x, the value will be same for any real value of x. Similarly, second, I have odd function. Okay, odd function is basically what? F of minus x is equal to minus f of x. F of minus x is equal to minus f of x. It has point symmetry about origin. You all know what is meant by point symmetry, right? Point symmetry means it is basically rotational symmetry. Like this is x, this is y. If a function is going something like this, so it on the negative side, it will just rotate by 180 degrees. Okay, just rotate it by 180 degrees.
Yes, sir.
So it will be something like this, something like this. Okay. I'm not able to draw it clearly, but this is what I try to say. One thing special about odd functions, like, okay, so just a few more examples. Y is equal to sine x, y is equal to x cube, then what else? Y is equal to tan x also. Yes, correct. Tan x, correct. Yes. Hello. Do you have a doubt? Okay, so tell me, what will be my f of 0 equal to in case of odd functions? In case of all odd functions, my f of 0 will be equal to,
0.
yes, obviously. See, because f of minus x is minus f of x, right? So you put x is equal to 0 over here. You put x is equal to 0. So basically f of 0 is equal to minus f of 0. So that means 2 times of f of 0 is equal to 0. So that means f of 0 is 0. है ना? प्रूव करने की जरूरत भी नहीं थी. It was such like it was so basic proof that I did not even need to prove it. ठीक है. चलो anyways. So okay. So so just a small homework problem. Just find out whether the following functions are odd or even. Okay. Just find out if the following functions are odd or even. The first is very easy. First two are really easy. You must have done by now, right? Third one is a bit tricky. You will need to use some algebra. चलो पहले दोगे तो आंसर भी बता दो यार, अभी जाने से पहले अपन आंसर भी कर लेते हैं.
First
Just of
one
first
is
two. First one is even.
even.
हाँ, first one is
Second
even. What about this?
odd.
Odd. Okay. Okay, so sign like I maybe I forgot to tell you something, or maybe like, do you know what this means? Two parallel
Mod.
lines.
Yes,
So
Yes,
sir.
it is
sir.
basically sine of mod x. It is not sine of x. Tell me. Now tell me.
Odd. Odd function.
It is even. It is even. Correct. Gayatri or Bhavna? Who was it? Or Ashrita?
Ashrita, sir.
Okay. See, like mod x in itself is also an even function only, na? Because mod x is basically what? Mod x is telling me that you give me any value, I will return its magnitude. So, like in case of mod x, either you put x or either you put minus x, it is same. And on top of that, I'm telling sign. So, like I
Yes.
don't care about sign. I don't care. I won't care about sign. This sign is useless to me because it is mod x now. So either I am putting x or minus x. It will give the same, return the same value. Okay. Yeah. So just a bit more tricky problems. Should I give bit more tricky problems? थोड़ा लेवल बढ़ाएं.
Yes,
बट
sir.
करके आना फिर. बट फिर होमवर्क करके आना, ठीक है?
Okay, sir.
Okay, sir.
So f of x is equal to sine raised to 4x divided by gif of x by 2 plus half, and x is belonging from -2 to 2. Okay. यार चलो इतना मुश्किल नहीं करते तुम्हारे लिए अभी. यू आर किड्स ना. रोने लग जाओगे ज्यादा मुश्किल दे दिया तो. यही ले लो चलो. एंड इट इज बिलोंगिंग फ्रॉम -1 to 1. सेकेंड यही सेम ही है, बस इसमें साइन एक्स हो गया. ओके. You told me, I guess, when I had asked you, you were born in 2009, right? 2009, I guess someone was born in. चलो ठीक है, इतने ही 6 कर लेना, अब मतलब 4 कर लेना. दैट्स इट. फाइन. दैट्स इट. ओके. थैंक यू. हैव अ नाइस डे. You have a break for 4 days. I am going for my convocation. The class is over. Thank you. If you have any doubt, you can ask. No doubts?
No, sir.
Okay,
No,
okay.
sir.
Okay, so like there will be a break for 3-4 days now. I am going to take my degree, and if possible, see, I'm just telling you, if possible, during some day I will come online with all of you to show you the campus of IIT. Would you like to have a look? IIT
Yes,
Roorkee campus?
Yes, sir.
Okay, okay, sure, sure. I will. So there is a like on 27th we have our convocation. So for that, I am leaving today. I'll be reaching there tomorrow. I anyways had to reach there tomorrow. So yeah, if possible, I will definitely give you a look into the main building and the campus inside. Okay, I will definitely try it during your class times. Okay, that's it. Yeah. So thank you very much. Have a nice day. Good night. If you have any doubts, please ask me. Ma'am, that's it. Please end the class.
yes, yes, sir. Thank you, sir. Yes, students, again we'll have class tomorrow morning, 5 to 7. Okay? Please attend the classes in the morning session.